In this video, we'll talk about an application of quadratic functions with minimum values. Our question is, a cost per item function is given by c of x equals 4x squared minus 32x plus $75 for x items. Our questions are, what is the setup initial cost of the per item? The cost per item is the least when you produce how many items? The minimum cost per item is what? The cost per item is the same as the initial cost per item when x is what? And to provide a labeled graph that shows each answer. To start with, we need to find the setup initial cost. Since c of x is the cost function, the initial cost occurs when x equals 0 items. c of 0 is 75. The initial startup cost is $75. Notice the importance of our units here, x items and $75. The second question is, the cost per item is the least when you produce how many items? Since c of x is a concave up parabola because the leading coefficient 4 is positive, the minimum cost will be at the turning point of c of x. We must convert c of x into turning point form. When we factor out our 4, we have 4 times quantity x squared minus 8. So on the inside, b will be negative 8, and b over 2 squared will be 16. We add 16 on the inside, so we're really adding 4 times 16, which is 64, so we need to subtract 64 to keep this balanced. Our turning point form is c of x equals 4 times quantity x minus 4 squared plus 11. The turning point is 411. The cost per item is at a minimum cost when x equals 4 at 4 items. What's the minimum cost per item? The turning point is 411, so the minimum cost per item is $11. Now we need to know when the cost per item is the same as the initial cost. The initial cost is 75, so we set c of x equal to 75 and solve. Because we have 75 on both sides of our equation, that cancels out and we can factor, and we get 4x times quantity x minus 8 equals 0. So either 4x equals 0 or x minus 8 equals 0. This gives us x equals 0 or x equals 8. X equals 0 is, of course, our initial cost. So the cost per item is the same as the initial cost per item when x equals 8 items. Here's a graph of our function with the 0.75 and the 8.75 points marked, as well as the 411 turning point. Let's check our work. Here we have two versions of our function, the standard version and the turning point form. At 0, both functions give us 75, that checks. At our turning point, both functions give us 11, that checks. And at 8, both functions give us 75, that checks. Our answer then is given by this graph with all the points marked. The initial cost is $75. Part 4, at 8, this is the same as the initial cost. And for parts 2 and 3, the minimum cost is at x equals 4 items and is $11. That's our turning point.